All right, so here's our first problem within the tangent line problem. This example wants us to find the slope of the tangent line to the graph of f of x equals x squared plus 1 at negative 1, 2. So if you can envision this function, it is a parabola, it's positive, and it's shifted up 1 unit. And then we want to determine the slope when x is equal to negative 1. So the first thing that we're going to do is we have to remember that this is our approximation for the slope of the tangent line at this point in time. And C is going to represent x, since in our previous example, that's what P represented. P had a point of C and then f of C. So C is going to represent x. Now, in order to do this, I have to understand what this is saying very carefully. I'm just going to rewrite the limit part right here, and it's delta x, and I'm approaching 0. This very first part, this f of c plus delta x, remember that that just means y2. Now, I don't know where y2 is, so I have to use this notation to help me. So I'm going to say f of c, which happens to be negative 1. I'm going to write negative 1. And I'm going to write my plus sign, and delta x, I don't know what that is. I don't know how close this other point is, but I want it to be as close as possible. So I'm just going to rewrite delta x. I don't know what it is. And then minus f of c, which is negative 1. That's the point that I'm approaching, and it's all over delta x, which I do not know. All right. So the next thing that we're going to do is we have to start plugging these x values into the function and see what I get. I'm going to just rewrite the limit part. And I'm going to color code some of this so that you understand where it's coming from. This part right here inside the red parentheses, all of this represents an x value that I plug right into this x. So when I do that, and this is probably going to look a little funky because we're not used to plugging in a full expression in for a variable. But I'm going to open up a bracket here and then a parenthesis, and I'm going to write this in red, that when I plug in negative 1 plus delta x into this function, that would give me negative 1 plus delta x, and then squared, because this is x squared, so this represents my x, and then I'm squaring it, plus 1, and I close parentheses. So all of this was as if I plugged that one red part into that function for x. And the second part, f of negative 1, this is just your typical plugging in the x value and seeing what you get. So when I do that, negative 1 squared, I'm going to do this one in green. So negative 1, and I plug that in. Squared is positive 1, plus 1 is 2. So I'm going to write that right here. And this whole thing, once again, is over delta x. All right. So we're making this work. We're getting there. All right. So let's keep this going. I'm going to rewrite my limit below, because this is going to be a little bit big, and I want to have room to write it. All right, so the red number is negative 1 plus delta x. I'm squaring that, and I'm going to do this business out here to the side. I'm going to go ahead and square it. So this literally means I have negative 1 plus delta x times negative 1 plus delta x. That's all that means. So we're going to do our foiling process. Negative 1 times negative 1 is positive 1. And then our outers is negative 1 times delta x, which is just negative delta x. And then my inside terms, which is going to give me another negative delta x. And then lastly, I have delta x squared. Combined, this gives me 1 minus 2 delta x's plus delta x squared. All right, I know that this doesn't look pretty, but that's what we got. So I'm going to write this right up here in the same color. 1 minus 2 delta x plus delta x squared. Okay. Now that was just that squaring part, so I still have this plus 1 business. And then out to the side, I'm going to be subtracting 2. And I don't need those parentheses anymore because everything that needs those parentheses is taken care of. The grouping symbols no longer are really going to change anything. And that's all over delta x. All right, so we can cancel a few things out here. For instance, this 1 plus this 1 gives me 2, and then I subtract 2. So all of these constants actually cancel each other out, which is really nice. And another thing that happens is I see that there's a delta x inside all 3 of the terms that are left over, which means I can take them out. So below here, I'm going to, once again, rewrite my limit notation. And if I were to take out a delta x from this first term up here in red, I would just be left with 2. For the second term, delta x squared, if I take out 1x squared there, then this is gone, and I just have plus a delta x. And what happens in the denominator is if I take away that delta x, that's gone now too. So this is all I'm left with, 2 plus delta x. The only thing I haven't done yet is taken the limit as delta x approaches 0. When I use my substitution rules, this would give me 2 plus 0, which is equal to, this is negative, I'm sorry, negative, it's equal to negative 2. And that number right here represents the slope, okay, or m, at that point, negative 1, 2. So that's how we're doing problems like that.